Hey there, geometry. We have a new program to try, so wish us luck. We're working with OneNote today. It's really small. I don't know how to make it bigger, which is really sad, but we're going to try it. I think I can write everywhere, so it's not going to be that big of a deal. So we are in Unit 2, Lesson 1, congruency. All of Unit 2 is congruency. So we're going to talk a bit about congruent parts, and this is part 1 of congruent parts. So let's look at notice and wonder. Transformed rectangles. So what do you notice? What do you wonder? Yeah, the smallness of this is going to bother me, but all right. So what do we notice? What do we wonder? Here, I notice that I have A, which is blue, and B, C, and D, which are green. A, all of the letters are like pre-image letters, where B, C, and D are all primes, which means they're image letters. And actually, if I look at it, it looks like I can reflect. All right, I'm going to pause this for a second and see if I can figure out my writing utensil. Oh, golly. I know. I'm going to pause it for a second, I think. All right, I think I got it. So, sorry, I'm outside right now because my family is playing Minecraft and Roblox, and they're really loud. And when I say family, I mean the boys. So I could actually reflect this over, let's say this is line M. I could reflect this over there, and Q becomes Q prime, P becomes P prime, S becomes S prime, and R becomes R prime. So that's a pure reflection. And I could actually reflect this again. Oh, sorry, let me get used to my tablet again. I could reflect this again here, and S prime, it should be S double prime, etc., etc. So B is a reflection onto D, or D is a reflection of B over line, let's say, L. But I could also say that this was a rotation. Like I could do A to D, a rotation clockwise 180 degrees, which is pretty cool too. I could rotate A all the way back to A as a 360 degree rotation. So this, what I notice is I see lots of reflections and rotations here, which take a figure onto a figure. Like the pre-image goes to any one of those images, depending on what we do to it. I guess I could continue. Sorry, let me move my paper. Pick another pen color. I could also reflect that one over here, and D becomes C. D reflects onto C over line, let's say, N. Okay, and then we would get back to the beginning. That reflection line is terrible. If this is a reflection line X, C would reflect back onto A. Okay, so that's what I notice. I don't know why A is blue. That would be what I wonder. That's it, really. All right, so let's keep going. Section 2 says, if we know this, then we know that. So triangle ABC is congruent to triangle DEF. And this is how we would write it in really cool geometry terms. And this is how I usually write things. I don't use the typed word triangle, I use the symbol triangle. I don't use the typed word congruent, I use the symbol congruent, which is right there and very small. But that symbol is congruent, and it looks like this. Okay, it's an equal sign with a squiggly over it. All right, so this says find a sequence of rigid motions that takes triangle ABC to triangle DEF. Sequence of rigid motions means more than one. So if I want a sequence, it looks like I would translate this will be nice. There's lots of extra room. translate triangle ABC by directed line segment, what is that? BE, that's B, sorry. By directed line segment BE, where B would meet E. And then I think I would rotate clockwise with center E until, oh, that's weird, until C coincides with F. Okay? And then I would probably reflect over line EF. And then everything would work. If you think about it, I'm going to erase all this, but if I translated it, it would look something like that. And then if I rotated it, it would look, oh golly, something like this. And then if I reflected it, it would, everything would coincide with everything else, okay? So let's erase all that. It's fantastic, just takes a long time when you do a sequence. What is the image? Let me get my pen back out. What is the image of segment BC after the transformation? So BC becomes EF. The image of BC is EF. Explain how you know the segments are congruent. So I could say a sequence of rigid motion holds congruency. Okay, a sequence of rigid motion takes one figure onto another. Everything stays congruent. Okay? And then justify that angle ABC is congruent to DEF. ABC is right here, and DEF is right here. So the definition of congruent is that there is a rigid motion that exists taking one figure onto another. Okay, so a sequence of rigid motions that takes one figure onto another means that all the pieces and parts are going to be congruent. Okay? All right. And let's talk about it just a little bit more, because this is really cool. I wish I could make this bigger. View. Ooh. There we go. So much better. All right. Let's go back to draw. So this right here, I just want to be able to talk about these pieces and parts. If I read this, it says that triangle DEF, if I read it, triangle DEF is congruent to triangle PQR. Okay, that's what that says. Just want to get that out of the way. What I highlighted says triangle DEF is congruent to triangle PQR. So that means that all of the pieces and the parts are congruent. That means I can say that segment DE is congruent to segment PQ, which we see it right here. Okay, segment EF is congruent to segment QR, which is right here. And then I can say the first letter and the last letter. Segment DF is congruent to segment PR, which is what we say right here. So those are all the corresponding parts of the triangle. Let me write that down. corresponding parts are congruent. So if we state that the triangles are congruent, we can say that the corresponding parts are congruent. Okay, make my pen a little smaller. We can also say that the angles are congruent, which is really cool. Let me change colors here. I can say angle D is congruent to angle P because it's the first letter in the triangle congruency statement. Angle P is congruent to angle D. I can see angle E is the second angle written, is congruent to angle Q because it's the second angle written, right there. And I can also say angle F is congruent to angle R because it's the third letter written. So that's all just the letters. I can do the same thing with the triangles. If we look at this triangle, PQR and DEF, P is in the same spot as D. Q is in the same spot as E, R is in the same spot as F. And notice how we show those. Single tick, double tick, double tick, triple tick, triple tick. That means that those angles are congruent. I can do the same thing with the sides. PQ has a single tick, it's congruent to DE, single tick. PR, double tick, DF, double tick. QR, I think that is, triple tick, EF, triple tick. Okay, so that's all. Those are corresponding parts. Okay, when we say the triangles are congruent, we know that the corresponding parts are congruent. And actually there's a really great acronym that I'm going to use through this whole unit and practically the whole year that says corresponding parts of congruent triangles are congruent. And I will say CPCTC over and over and over again. Corresponding parts of congruent triangles are congruent. Okay, so push pause and write that down. It's important. Okay, moving on. All right, making quadrilaterals. Let me get to my right page in my book. All right, so here, let me push pause for a second. All right, I just wanted to see if there was an applet in your curriculum. So here, I'm going to move this up just a little bit. All right, so let's look at this. Now, if we had our, actually I'm going to go into GeoGebra because if we did this in the classroom, we would be using our compass and straight edge, okay? So I'm going to go into GeoGebra. Give me a second. I've got the instructions written in front of me and you have the instructions written in front of you, so it's fine. GeoGebra, geometry. All right, step 1 says draw a triangle. Let me get more. I always need all of the things. All right, so we're going to draw a triangle. And now it says to find the midpoint of the longest side of your triangle. If we did that with our compass and straight edge, we would be drawing 2 circles and seeing where they intersect, and that would be our midpoint. I'm just trying to get like a definite longer side. There we go. So I would, and I'm going to try to do it old school, like if I had a compass in my classroom. So I want to draw a circle, and BC is my longest side. I need to go past the midpoint, and I have to copy this circle and put it at C. Now where these intersect is where my midpoint is. Let me find the intersection. I want to mark those intersections. So this is how we would do it if we had a compass and straight edge in the classroom. And I'm going to do, let's see, does it say to, let me find the instructions. Yep. Doesn't matter if I do a line or a segment. Oops, nope, we don't want that. Undo. Undo. There we go. It's right. We'll do a segment. It didn't matter. So that right there is the midpoint of BC. Okay, now looking at my instructions, it says rotate your triangle 180 degrees using the midpoint of the longest side as the center of rotation. So let me mark a point there using my intersection. So I'm going to rotate it 180 degrees using point G. So let's find that rotation, transform, rotate around a point. So select the object and the point, and I want to go 180 degrees. If we were doing this with paper and pencil, it'd be much more difficult. Cool. Label the corresponding parts and mark what must be congruent. All right, I'm going to take a screenshot and see if I can move this into the program I was using for annotation. That was loud. All right, I'm going to go over to OneNote and see if I can paste it in here. It doesn't like that, does it? There we go. All right. So here are the instructions still. Label the corresponding parts. So we know that this is so cool. All right, cool. So I'm going to label the corresponding parts. A, B, what is it corresponding with? Corresponding with C, A prime. Okay, which is sort of silly, I know, but I can mark tick mark and tick mark. I can also say that AC prime is congruent to or is corresponding with BA. So I want to mark that with something different. So 2 tick marks. And then the diagonal here is actually corresponding with itself. So 3 tick marks. And then I can say that angle A corresponds with A prime. So I'm going to do one little arc. Angle ABC prime corresponds with this one. And notice how I do 2 arcs like that, not 1 arc with 2 ticks. Same thing, it's okay. And then here I'm going to have 3 arcs because it corresponds with that one. So I marked all the corresponding parts. Make a conjecture and justify it. My conjecture is that I just drew a parallelogram. I can say that A, B prime, A prime, C prime is a parallelogram. Parallelogram. Okay, I can see that it's a parallelogram. And we can say this is actually a quadrilateral. Is a parallelogram. Okay. The opposite sides must be parallel. The opposite sides are parallel because we did a rotation 180 degrees, and we've learned that a rotation 180 degrees makes parallel, oops, nope. I pushed the wrong button on my pen. Oh my gosh. I'm so sorry. Every once in a while I do that. Makes parallel lines. So we actually know that these lines are parallel. That's how you mark things parallel. And those lines are parallel. Okay. What else? Ooh, here's a good one. Let me get a highlighter. Here I set a parallel line, and here's a transversal. So we know that alternate interior angles are congruent. Okay, those are alternate interior angles. So those are congruent, therefore the lines are parallel, or the lines are parallel, therefore the angles are congruent. Either one works. I can also say that these are parallel lines. Sorry. And that's my transversal. So these alternate interior angles are congruent. So we know that lines are parallel, therefore the alternate interior angles are congruent, or alternate interior angles are congruent, therefore the lines are parallel. Okay? All right. I think that's it. Okay, that was pretty cool. So we're really building some skills on talking about congruency and corresponding parts. And remember, CPCTC. Okay, CPCTC. Corresponding parts of congruent triangles are congruent. All right, that's it for today.